2 tape on finding volume. What I wish to do on this tape is to do the washer method. So let's look now at the concept of the washer method. Let's say, looking at example 1, reading it, it says, find the volume generated if the area bounded by the curve y equals x squared and the line x equals 2 and the x-axis, of course, is revolved about the y-axis. We're going to revolve it about the y-axis. Now, if I take this strip right here and revolve it around the y-axis, what I form is what's called a washer. This is the strip right here, revolved around, will form a washer type solid. Well, what is the volume of a washer? Now let's just go back to old high school math formulas and figure out how much metal there is in that washer. Well, what I could do is take this radius, this outside radius, this large radius, and find it. That would be the pi r squared. That would be the area times the thickness, which is h, or which in our case is dx or dy. And then subtract from that the inside area. I'm going to subtract away this whole. And that would be pi r squared dx or dy. Well, I can factor out the pi, and I can factor out the dx or dy, and what I have is radius squared minus radius squared, where this radius is the outside radius, and this radius is the inside radius. So the washer method concept is to find the large radius, that's that volume or that area, which is pi r squared h, and subtract from it the inside. Well, rather than doing two problems in one, we will just put it all together as a one formula situation. So let's look now at the memorization process that you memorize for the washer method. It is the outside radius squared minus the inside radius squared times pi times the thickness, either dx or dy. Now, let's go back and look right here. What is this outside radius and what is the inside radius? What am I talking about here? Looking at the figure, if I revolve this strip around the y-axis, the outside radius is this distance from here to here. We'll call that x right minus x left for the outside radius. But we also have to work the inside radius. We'll call this x right, x left for the inside radius. So what does this mean? Looking back at in your notes there, you have the volume is pi times outside radius. What is the outside radius? The outside radius is the y top, y bottom, or x right, x left. Okay, now listen, that y top, y bottom is not the length of the strip now. This y top is the end of the strip back to where you're revolving it about. All right, let's look at the x right minus x left at the figure. X right would be this x value, which is 2, and x left would be this value, which is 0. The outside radius would be this x value minus this. The inside radius, which is also x right, x left, the inside radius is this x right minus this x left. So it would be this x right, which is, in this case, what x is equal to. That would be the square root of y. X would equal to the square root of y minus the inside, the x left here, which is 0. Now what I want you to realize is the washer method is outside radius. Now how do you get this distance from here to here? Well, that's x right minus x left. That's squared. Minus the inside radius, which is what this x is minus this one. All right. I hope you see that. If you don't, well, follow through as I keep repeating it over in these examples. Let's now do example 1. Look at this figure. We're going to do this problem. We want to find what the volume is generated when this area is revolved around the y-axis. Therefore, we write down volume is equal to pi integration of, since the strip is this way, it'll be x right, x left, squared. And remember, this is for outside radius, minus x right, x left, squared for inside radius. Now, you can look at the figure as I just point here. What is the outside radius? Looking on your paper now. The outside radius, x right is 2, x left is 0. That's squared. The inside radius, x right is the square root of y, x left is 0. Alright, so we have dy and 0 to 4. Okay, since it's dy, then the strip is moving from 0 up to 4. And then we work it out. 2 minus 0 is 2, squared is 4. Square root of y minus 0 is the square root of y. Squared is y, dy from 0 to 4. And then you integrate this 4y minus y squared over 2 from 0 to 4 and plug it in, and you come out with 8 pi. Now let me go through this one more time to show where I get all this stuff. One more time. Let's go back and do the x right, x left, x right, x left. Outside radius. Outside radius. How do I come up with this 2 minus 0, and how do I come up with this square root of y minus 0? Let's go look now at the figure. Now, the outside radius, that's this right here. What is x right here for this brace here? Outside radius. X right is 2. X left is 0. That's the outside radius. That's squared. So it'd be 2 minus 0 squared. What is the inside radius? The inside radius is this brace. The inside radius, x right is what? The square root of y. What x is equal to? What x is equal to on this curve? X left is 0. So the outside radius is 2 minus 0, that's squared, minus the inside radius, which is what x is equal to here, square root of y, minus 0 squared dy. Now, we're going to integrate from 0 to 4, I said. How did I get that? Well, of course, this is 0. This strip is going from here to here. What is y here? Y along here is 0. What is y here? Well, x is 2. X is 2. So when x is 2, plugging in the original equation of the curve, since x is 2, this would be 4 for y. And so that gives me my limits from 0 to 4. All right. So therefore, this is how we come up with this pi times the integration of 0 to 4, 2 minus 0 squared minus the square root of y minus 0 squared. This squared is a 4, this squared, and so on and so forth. All right, let's look at example 2. Example 2 says this. We have the curve y equals 1 minus x squared and the x-axis. We want to take this area and revolve it about the line y equals 1. Now again, how are we going to draw the strip? If we draw it this way, it kind of touches itself, and so we don't want to use that necessarily. So we'll draw the strip this way. Drawing the strip this way and revolving it about y equals 1 makes a washer. Where the outside radius and inside radius. Now, the outside radius is y top minus y bottom. Inside radius is also y top minus y bottom. So, when we get a washer going up and down, then we get the formula pi integration of y top y bottom squared minus y top minus y bottom squared, instead of x right, x left. It's still the same concept. This is the outside radius. This is the inside radius. Now, what is the outside radius? All right, look at the figure. The outside radius is this distance. So that's y top, which is what? 1. Y top is 1. Y bottom is 0. So, y top is 1, y bottom is 0, and that's squared. Of course, that's 1 squared, and that's 1. Okay? Inside radius, looking back at the figure, the inside radius is this distance. The inside radius is the y top, which is the 1, minus the y bottom, which is what is y equal to on this curve, which is 1 minus x squared. So, coming over here, y top for the inside radius is 1. Y bottom for the inside radius is the curve. So we have 1 minus the parenthesis 1 minus x squared. Removing parentheses, the 1's drop out. This changes this to a minus. Squaring that comes out to be x to the 4th. And then the minus between them is this minus. All right, limits. How do we come up with the limits? Minus 1, 1. Let's go back over here to the curve. The limits, it's dx, so it's what the x values are as that strip moves from here to here. So we have to figure this out. Well, when y is 0, what's x? When y is 0, put a 0 here, move the x across, get x squared is equal to 1, so x is a minus 1, 0, and a plus 1, 0. Therefore, this strip is moving from a minus 1 to a plus 1. And that's how we come up with the limits. All right, then you integrate. Integration of 1 is x. Integration of x to the 4th is x to the 5th over 5 from minus 1 to plus 1. Integrating that, working it out, and then times pi, you get the answer in your notes. Okay, let's look at example 3. Okay, example 3 says, find the volume generated bounded by the curve, this line right here, which is x minus 2y plus 4 equals 0, and the parabola, which is 4y is equal to x squared. If that area is revolved around the line y equals 4. Now here we cannot draw the strip this way because when it comes down here it changes. So the strip must be drawn up and downward. Now if I take that strip and revolve it about that line, I get a washer. Well, what is the washer method? The washer method is pi times outside radius squared minus inside radius squared. Now let's go back to the figure and find out what outside radius is and what inside radius is. Outside radius is this distance right here. That's y top minus y bottom. What is y equal to up here and what is y equal to down here? Inside radius is what is y equal to up here, what is y equal to right there. All right? Now, Outside radius, what's y equal to here? That's 4. Minus, what's y equal to here? That would be, solving this, would be x squared over 4. Y would equal to x squared over 4. Inside radius, what is y equal to? That's 4. What is y equal to? Solving this, you would get y is equal to 1/2 x plus 2. So let's look now and follow the rest of the work in the notes. Outside radius is y top minus y bottom squared minus inside radius y top y bottom squared. What we said before, for the outside radius, what is y top? I guess we'll just go look at the figure again. Y top, outside radius, y top is 4. Y bottom is what y is equal to. So the outside radius is y top is 4. Y bottom is what y is equal to, x squared over 4. All that squared. And all that squared, you can work it out. All right? Inside radius. Inside radius. Look at the figure. Inside radius is y top minus y bottom. Okay, y top then is 4. Y bottom is what y is equal to on that straight line, which is 1/2 x plus 2. All that inside here squared. Well, let's see. Let's simplify this. If I remove parentheses here, that would be a minus 1/2 minus 2. 4 minus 2, this would make this a 2. Now I want to square everything. So look at the next line. If I square this, the first one squared is 16. This times this, 4's divide out, doubled is a minus 2x squared. This last one squared is x to the 4th over 16. Minus, now I'm going to square this. This squared would be 4, so it would be minus that 4. This times this would be x, a minus x. Double is a minus 2x. Times the minus is a plus 2x. The last squared would be x squared over 4, positive. Times this minus would be a minus x squared over 4. Then, grouping, simplifying, the 16 and the 4 add up to 12. Then we have this plus 2x. We have the minus 2x squared, but wait a minute, we have another x squared. We have a minus 2x squared and a minus a 4th x squared. So we have a minus 2 and a 4th. Minus 2 and a 4th x squared, which is minus 9/4 x squared. Then we have an x to the 4th, which is the x to the 4th over 16. And then now we need to talk about the limits. Okay? Now, where did I come up with the limits of minus 2 and 4? All right, now, if you're working this, look at the graph. If you're working this, I already have it written down for you. But if you started out, you wouldn't have these right here. So how do we come up with that? Well, that's where we have to solve these two equations. Look, 4y is equal to x squared. And x minus 2y plus 4 is equal to 0. Let's solve those. Well, what's y equal to in this? Y is equal to x squared over 4. What is y equal to here? Y is equal to 1/2 x plus 2. We already worked this out. We had to do this for our y top, y bottom. Look, if this is equal to y, and this is equal to y, then this is equal to this. Therefore, x squared over 4 is equal to 1/2 x plus 2. Multiplying through by a common denominator, multiplying everything by 4, we get x squared is equal to 2x plus 8. Moving that all across the other side, we get x squared minus 2x minus 8 is equal to 0, and that factors x minus 4, x plus 2. So x then is equal to a minus 2 from here and a positive 4 from here. So these points of intersection on the graph is x is the minus 2, and over here x is the 4. And that's how we come up then with the limits of minus 2 and 4. Okay, let's look now at example 4. Example 4 says we want to find the volume generated if the area bounded by the curve x equals 3 and the parabola x equals 3y squared is revolved around the line x equals 5. So if we draw the strip this way and we revolve that, we form a washer. Since it's a washer method, it's pi times the integration of outside radius minus inside radius. Well, since the strip is drawn level, horizontal, then outside radius, inside radius is x right, x left concept. Now, what is this outside radius? What is this x right, x left for the outside radius? Go back and look at the figure. The outside radius is this. So x right minus x left. What is x equal to? It's 5. What is x equal to? 3y squared. So, for the outside radius, x right is 5. X left is 3y squared. All that in parentheses squared. Then minus inside radius. Looking back at the figure, what is the inside radius? For the inside radius, x right is 5, x left is 3. No matter where you put that strip, it's still 5, it's still 3. So for the inside radius, x right is 5, x left is 3. All right, squaring this will then be 25 minus 30 y to the 4th plus this would be 30y squared plus 9 y to the 4th. Okay. Then minus, this is 2, and 2 squared is 4. All right, that's times dy. Now, where did I come up with the limits? Minus 1, 1. Well, let's go back and look at the figure. This strip is moving from here to here. It's dy, therefore I've got to have y values. Look, if this is x equals 3, then if I plug a 3 in here for x, I get 3 equals 3y squares. 3 is equal to 3y squared. 3 is divided out, I get 1 is equal to y squared, so y is equal to plus or minus 1. So this point is x is 3, y is a minus 1. To this point, x is 3, y is 1. Since it's dy, I'm going from the y's to the y's. So my limits are minus 1 and 1. And then you can follow your notes, the rest of the algebra here. Simplifying here, I can subtract the 4 from the 25, get 21, and then integrate and work it out. All right, let me say one other thing about these kind of problems. The washer method is only necessary at a few times. Let's go back and look at example 3 in your notes. Example 3 in your notes. There is no other way of working this in practicality. Now, it can be done with a lot more trouble. But in practicality, this one is the only way you can draw the strip. And so when I revolve this area about this line, I just almost have to use the washer method. However, most examples that we've worked, and you will work on your homework and teachers' work, the washer method could have been done by the shell method. Let's go back and look at example 1, done by the washer method. Example 1 by the washer method was if we have the curve x squared is equal to y and x equals 2, we want to find this volume revolved around the y-axis. And we drew the strip this way. And then we revolved that and made a washer. We could have worked this problem by the shell method. Okay. We could have worked the problem by the shell method, and it would have been 2 pi integration of x right minus x left, y top minus y bottom, dx in this case. All right, now revolving this around the y-axis, then we would have 2 pi x right, x left is the arrow, so that's x minus 0 y top is x squared, y bottom is 0, dx. And going from 0 to 2. Okay, this strip is going from 0 out here to x equals 2. We only have to solve for this intersection up here. And then we end up with the integration of x cubed dx, and that integrates to x to the 4th over 4 from 0 to 2, and we get the exact same answer. This is 4 times the 2 pi, which is 8 pi. It ends up being maybe a little easier this way. Now, what I'm trying to tell you is this. Two things. Number one, you don't worry when it gets to test time. You don't worry which way you draw the strip so much. The only thing you worry about when you draw that strip is that it touches the same different curves as it moves. As you take that strip and move across, this y top better be the same curve all the way across. And y bottom better be the same different curve all the way across. If you draw it this way, then x right better be the same x right. And x left better be the same x left all the way. Okay. That's the only concern. The second concern then is if I take that strip and revolve it. If I have it this way, if I revolve it this way, does that make a shell or a washer? Okay, well in this case that would make a shell. If I revolve it this way, around this way, does that make a disc or washer? Well, if I take the strip this way and I have my axis here and I revolve it around that, that makes a disc, nickel. If I have the strip and I have my axis that doesn't touch it and I revolve it, then that makes a washer. Then you say, okay, disc is, and you memorize, disc is pi times the integration of, parentheses, y top, y bottom squared, or x right, x left squared. Okay. If it's the shell method, then it's 2 pi, x right, x left, y top, y bottom. If it's the washer method, then it's outside radius, y top, y bottom squared, inside radius, y top, y bottom squared. And you just have to memorize that. So two things you got to do. Number one, basically, you got to draw the strip so that it touches the curves all the way across, the same set of curves. Number two, then you have to say, hey, what does it form? When I take that strip and revolve it, what does it make? Does it make a washer, a shell, or a disc? Then, whichever one it makes, then you're supposed to have that formula memorized. Okay. So when the test comes around, you got to worry then about, just drawing the strip, and then what I get. Okay. Now on your homework, like one homework exercise, you do all washer. Another homework, all shell. Another homework, all disc. But when the test comes together, what I like to show you is that the washer and the shell method, almost all problems, not all, but almost all problems can be done by the shell method that could have been done by the washer method. There are a few cases where that's not true, and that's why you need to know the washer method for one of the two examples that you cannot do it any other way. Again, what I'm saying to you is if you know the disc method and the shell method, you can work almost all problems. In actuality, you can work them all. Okay. It'll just make it the washer method makes it a little easier sometimes. Okay. This then concludes the tape on finding volume.